I'm going to go over how to build it. It is quite straightforward, sort of. This is the easiest I could make it to build, so basically anybody can follow it. This on here is just a reminder to me what the minimum and maximum battery voltage is that I need to charge it to, and also the minimum I can have it discharging at. And that's displayed on the bottom there, so that's at 32.7 volts at the minute, which is basically fully charged. So what you need obviously is the casings first, which I've already tidied up, cleaned up and got all prepped and ready. I'm going to cover these with vinyl, carbon fibre vinyl, purely because it looks better. No other reason. You don't need to do it. I've already put the fans in place, that was easy enough. I used hot glue in the end, it just makes it a lot easier. So what you need is obviously one of these. You can use any single one. The DPS 3003 obviously is the cheapest. If you want to buy that one, go for that one. You need a 20 amp switch, an XT60, but you do need both ends. That will become apparent as I go along. It's just for soldering the connectors on. I always recommend when you're going to solder anything, put the two ends together so it keeps the pins in line, because as soon as you start heating that up, it starts melting the plastic and then you find that it's just not lined up anymore. You need a JST. Is that a JST? And obviously the accompanying part, that is purely for charging. That's alright for 3 amps, you're fine with that. And obviously a BMS. Sorry, this is an active balancer, it's not a BMS. Now the reason why I've gone with these is I don't like those BMSs. Number one, I don't know what they're doing. Number two, I've seen horror stories over them, seen them burst into flames with no current or virtually no current going through them. I much prefer to manage the battery voltage myself. Now 33.6 volts there, 33.6 volts, there's a lot of things that run on that voltage. I'll put a link in the description to a charger that you can run on this, but I don't advise you putting any more than, what, 3 amps into it. And the reason why I'm using this is because I like to manage the voltage myself, and I know this will cater for transferring any low voltage to the high voltage cells and the high voltage to the low voltage. These handle it a lot better in my eyes anyway. And you don't lose any power with it. With normal BMSs, if you get a low voltage cell, it brings the rest of them down to that voltage. So that's the ones I recommend, and they are cheap as well. Now with all these parts, everything, there's going to be a link in the description. So the STLs, every single part, so you can go and add the lot to your basket and away you go. And they're all available, I think, from Banggood. So the first thing I'm going to do, I'm going to cover these. The only things I cover is that and that. The rest of it, because it's heat shrink, you don't need it. Obviously the heat shrink actually forms part of the cooling, so you do need to add that. But the carbon fibre covering, you can just leave that open blank if you want, it's up to you, I ain't bothered. What I'm going to do next is I'm going to epoxy the XT60 in. Now this is 12, I think it's 12 AWG. Yeah, I'm using 12 AWG for the main power wires, which is going to be plenty. This is going to be drawing, what, 5 amps, I think. When you're soldering these things, if you get some pliers and you bend those so they're flat like that, you can then put the whole plug flat on the table like that, and then you can fill those with solder a lot easier. And then you put something on top of it to hold it in place, and then you can just solder the two pieces on there. Obviously when the wires are in, you fill that with epoxy to make damn sure that that does not come out. I've got to be quick before this epoxy goes off. Put some epoxy around there first and then slot it in place. If you do it the other way and put the epoxy in the hole, literally you'll be gluing everything together. So put the epoxy in there first, push it out to the right place, and then hold it in position, and then fill that hole with epoxy like that. Now while I'm at it, I've got to make sure that stays in the right place, obviously. While I'm at it, I'm going to do the charge port, which is your JST. Literally all with that one. I'm just going to put it through there somehow. Put it through there, hold it in place, and then just put a blob of epoxy around the back side of that, and that'll be fine. With this thing, you're going to have to cut the tabs off. I tried to design it with slots in the side, but it made it so hard to get in and out. I had no choice really. Anyway, it slides in. It is a tight fit, so it ain't going to come out again, especially when the wires are in place. You will have to take this connector off, but obviously you need to take the connector off to wire it up anyway, which afterwards goes in there. I fitted the switch. This wire here, it doesn't matter which one you choose on here. You could use that one or you could use that one. You might have to bend these over as well, because the base plate will probably bind with the connectors, with the spade connectors. So anyway, this one here goes to the battery. This one here will go to the input on there, which is that one, which is going to be, that's that one. So I've connected, this is the negative to the battery, this is the positive to the battery. These two here go to the main output on the XT60. Hopefully you can see which way I've wired it. So that, and it does get a bit tight at this point. That goes in there, and then that'll slot back in there. So you've got that. When you do these wires, which are the main battery wires, what you've got to remember is the length of the cable that you need to run down the bottom. Now depending which way you put the cells, it doesn't matter. You could put the positive pointing down or up, or, you know, it just doesn't matter. But what you've got to remember is the length of the cable that you're going to need. So with these, when I can find a bloody 18650, so with this particular build I'm going to be doing it that way. So as the positive will just come to here, and then the negative will run down to the back of the battery. That's the reason. You've just got to bear in mind the length of the cable that you need just to run down the battery, the back of the battery. The other thing you need is one of these, which is a step down converter. I don't know if they call them a buck or a whatever, I don't care. These step the voltage down from the main battery voltage, which is 33.6 volts, down to 12 volts for the fans. So what you need to do is, where's the input? You put your positive and negative on there, applied 33.6 volts, and then you measure that and you adjust the pot to knock it down to 12 volts. There's one or two ways you could do it. You could either build the battery first and get the output from that, connect it to the input on that, or get a bench power supply like I've got, apply 33.6 volts and then adjust it to get 12 volts out. So with that regulator, the buck converter, the boost, no not boost, it's a buck, it's a thing, it knocks the voltage down, okay. With that thing, the only place you can put it is there with the pot at the top, purely because I designed this so compact that that is literally the only place it will fit, and the clearance is ridiculously low. So I should have made it bigger, I suppose, but I wanted to make it as tiny as possible. As I've already explained, my positive is going to be this one here, and my negative is going to be, is it going to be that one? Yeah, it's going to be that one there. So what I've got to do is, this piece here is going to go to the battery positive, sorry, is going to go to the switch positive, which is that wire there. So I need to spot weld across there, and then I need to spot weld across there, and then I need to spot weld across there. So I'm going to spot weld this up, and then I'll come back. I've got to do the parallel and the series spot welding, So the parallel across there obviously, and then the series, which has already got the cutouts. You can't accidentally go across there unless you're completely f***ing stupid. I'm going to use my spot welder. If you haven't seen the review of this, there's going to be a card up there somewhere. There, now. Go and have a look at it. A fantastic piece of kit these are. By far my favourite spot welder so far. The only thing I've done, I've modified the pedal and put a longer cable on it and a lot thinner, and it works out. Oh, that's very long. That's what she said. I'm going to cut all the nickel strips and then I can spot weld it all together. I found a quicker way of doing these. If you get them all on the table and just spread them out so as none of them are touching each other, and you get a wallpaper scraper and literally you do that and flatten them off. I'm going to give this a go. I've got a lot of spot welds to do and it does start taking its toll on your hands. So I am going to try this. We'll see. Wow! I couldn't have done all them in one go. The next thing I've got to do is I've got to check the voltage of the series cells, purely to make sure that they're all exactly the same. Well, near enough exactly the same. Near enough exactly. Make sure they're about the same. I'd say anything up to about, to be 100% safe, a quarter of a volt. 29.4. 29.3, 29.3, so I know we're in the ballpark. So now I need to measure the voltage of each cell, just the parallel one, so I need to make sure that that and that are all at the same voltage, because when I put the parallel connection across there, if we've got one that's completely duff, the rest of them will charge to it, try to charge it rather quickly, and that's when squirrels die. They're all about the same. There's a couple of millivolts difference, that's it. So now what I can do is, obviously not these but different ones, I'm going to put the parallel links on. Now every one of these has got to have a parallel link both sides, across there, across there, across there. So as you know, if you parallel cells up you keep the same voltage but you actually double the capacity, so this will have 3 times the capacity of that, if you get my drift. I might have changed the design slightly by the time you see this, but that's the way that I do that, which is, as you can see, the positive off the switch, and then it goes straight through those holes and it's spot welded to the positive side. Now as I say, I might have changed it. I think what I might do is I might move those holes further forward so as you've got a lot more clearance on the balancer. I'm going to have to insulate that, but that's how I've done it. I've just wrapped the nickel around the wire and soldered it in place. Hopefully you can see how I've done the negative side. Now there's no rules of what sort of method to use. This has then got a thread through onto the negative like that. You don't need any insulation because the negative is negative. Even if it wears through on there, it won't cause a problem. You hold that in place like that, and you very carefully, without actually touching the other bloody terminal, the positive one there, because that will be very bad. Oh, it's on. Make sure it's switched off first, and then you cut that to length, and then you push that over there. One, 2. And then I'll do another few. I think I'll just put some insulating tape underneath there just to be certain. You don't need it, like I say, because it's the negative. It's not going to cause problems. So now that should fit in place. I've taken the positive off the buck converter and I've taken that to the positive on the switch, so as when the switch is activated the fans come on. I've taken the negative off the buck converter and I've connected it to the battery negative, directly to the battery negative. The charge port, which is these two here, the positive goes to the battery positive and the negative goes to the battery negative, which is actually this wire here. So as you can charge the battery without it actually switched on at all. It doesn't need to be switched on. Now I've got to explain how to wire this active balancer up, purely because some people aren't familiar with them and they haven't seen any of my other videos where I repeatedly explain it, so I've got to explain it again. So this black wire here goes to the battery negative, which is that connection there, and then the next one, which is that one will go to the first positive, and then the next one, which is that one, will go to the next positive, which is that one there. You can see it's stamped positive, and then it will be positive, 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 and finally, which is the last one, will go to the battery positive, which is that connection there. So they are relatively straightforward and easy to wire up. Now I'm going to solder these in place. Just a tiny little dab of solder, that's all you need, very quickly, in and out. I mean, you don't need to solder it there. You can solder it in the middle there, you can solder it basically anywhere on there, or even down here, wherever you can get to that's safest for you and easiest. So what I might actually do is put that there like that, and then I can solder in the middle rather than soldering directly onto the battery connections. The final part of wiring the balancer is you get the connector, you put the probe negative, which is the black one, onto the black wire, and then you get your positive and you put it onto the first cell, and it should read 3.7-ish volts. There you go. And the next one should be 7 point something or other, and then it should keep going up in sequence, and then that's the battery voltage, which is the last one, which is 29.3. If they're not going up in sequence, it means that you've got one of these wrong somewhere and you need to revisit it. So now I'll get that out of the way. I'll put my other glasses on so I can see, and I'll bend that over a bit to make it nice and square, and then fingers crossed we don't get a fire. We don't have a fire. Oh, that's good. The final test. Yay. So the fans are on, although they're upside down, it doesn't matter. I'm going to check the output, if you can see that. Bang on 5 volts. Absolutely fantastic. Now obviously I don't know if it actually works properly yet, as in I don't know what current it's going to be delivering if it works. But what I'm going to do now, I'm going to get the heat shrink, I'm going to put it on there. Job's a good one. So if you overlap it on the back end about 1 inch, because you want that to wrap round there, and the front end, cut it to the front of this, purely because you want this to sort of go to about there when it's shrunk. After it's actually attached, I trim it down. Final part is literally cut the bottom piece off. Job done. It's perfect. So I can now do the most satisfying part and take that off. A word of warning, Leave this alone for 10 or 15 minutes to let the static electricity dissipate, because if you take this off a table now, this stuff is lethal for static electricity. What happens is it'll discharge and you'll fry that. I'll tell you that now. Don't ask me how I know, but it will happen. Leave it to discharge yourself, jobs are good. Give it a like and a thumbs up and stuff like that, because it's taken me days to work on this, believe it or not, because I have to keep stopping and resting and shit. Not shit. Well, yeah, they've got that as well. Oh, I haven't cut that off. I'll trim that off. There you go. Like, share, subscribe. All the plans, all the parts, absolutely everything is in the description. Everything that you could possibly need, apart from things like silicone wire, that's up to you. I don't advise, or I advise that you don't use the same silicone wire that I used. Use some thinner gauge. You don't need that heavy gauge, and it's a bastard to get it in. So use thinner gauge wiring and everything will be fine. So there you go.